Okay, so today we're dealing with adding and subtracting unlike fractions. Again, unlike because they don't have the same denominator. So what we're going to do is we have to change it. We have to change it so that they do have the same denominator. That's the only way we're going to be able to add the fraction. So let's go ahead and get started. Let's start with adding. Letter A here, 1/6 plus 2/3. 1/6 plus 2/3. Go and write that down. All right, so what we can see here is we have two fractions. One has 6 as the denominator, one has 3 as the denominator. So we can't just add across like we did yesterday. We can't just say 1 plus 2 is 3 and that's it, because we have 6 and a 3 different on the bottom. So what we need to find is we need to find the LCD, right? The least common denominator, the number that they both have in common, both 6 and 3. So there's a couple different ways you can do this. The first thing that I would think about is one of those numbers the LCD? Now, we know it can't be the 3 because 6 doesn't go into 3. That doesn't make sense. But it could be the 6, right? You could always try the bigger number, right? The LCD is always going to be either bigger or the same as one of the numbers, right? It's either bigger than both the numbers or possibly the same, okay? It can't be smaller. So we look at it and we think, well, yeah, 3 goes into 6, right? That's pretty simple. So I think 6 is going to be my LCD, because 6 goes into 6 and 3 goes into 6. So my LCD is 6, so that means I can say, all right, well, perfect. This one is already in 6 at the bottom. And this one, I just need to multiply by 2 over 2. All right, so let's go ahead and do that. And we say, all right, so we go and do that, and we say, all right, well, 2 times 2 is 4. 3 times 2 is 6. Okay, same denominator now, right? Let's go ahead and add those together. 1 plus 4 is 5 over 6. So again, with unlike denominators, you need to find the denominators, right? That's the same. And then it just becomes like a like denominator problem, like a like fraction. Let's try one. Let's give you guys one to work on. Negative 1/3 plus a negative 1/4. Go ahead and see if you can figure this one out and put the answer in the chat once you think you got it. Negative 1/3 plus a negative 1/4. All right, thank you. I've got a few answers in the chat. Thank you. Keep them coming. I'll let you guys know. I'll let you know in a second if you got it right or not. All right, 3 and 4 are my two denominators, right? So I need to find one, the number that's in common, but the smallest number that's in common. So here are the multiples of 3. 3, 6, 9, 12, 15, 4, 8. Well, there we go. I found the match, right? You guys probably knew that. 12 is the match. 12 is the common denominator. So let's go ahead and change both of these to 12ths. I want 12 on the bottom of both. So it means I got to multiply this one by 4. Now, remember, negatives, right? Negatives. When you see negatives, the alarm should go off on our head saying, okay, I got to be extra careful here. Negative 1 times 4 is negative 4. Plus, this one I got to multiply by 3, top and bottom. Negative 1 times 3 is negative 3. Okay, now decision time. I got negative 4 plus a negative 3. Some people say, well, Mr. Leong, negative and negative make positive, right? Remember, that was only if you're multiplying. This one is 4 ninjas and 3 ninjas is 7 ninjas, which most of you guys put in the chat for me, right? Negative 7 over 12. Pretty good? Let's try a subtraction problem. So let's move along. We're doing really well here. Again, the key with subtraction is going to be the same thing. Find your common denominators and then just do the integer math, right? 5/8 minus 1/4. Thank you. Thank you. Good job. All right. Thank you guys for putting the answers in the chat. I'm seeing a couple different answers here, so we'll have to kind of go and figure this one out. Remember, you're doing subtraction, so keep switch change might be a good thing to do for some of you, maybe. All right. Now, let me show you what happens, okay? You don't have to write this down, but let me show you what happens if you use not the common denominator, not the least common denominator. So let's just say you're like, well, you know what? Let me just do 4 times 8, and I know 32, right? So this is an example that you shouldn't do, but it'll still work. It just takes extra work, extra steps. So let's say, well, I think 32 is a common denominator. It is common. It's just not the least common. Let me show you. So I got to multiply this one by 4, so I get 20, minus, I got to multiply this one by 8, so I get 8. Now remember, keep switch change here. So 20 over 32 plus a negative 8 over 32. All right, so I'm left with 12 over 32. Now, here's the problem with not doing the least common denominator, is now I have to simplify this. So now I have to do the extra steps. Okay, so what goes into both 12 and 32? Well, 2 does. But so does 4. So let's use 4. All right, so 12 divided by 4 is equal to 3. 32 divided by 4 is equal to 8. All right, so there you go. I did get this answer right here, 3 over 8. Now, some of you, and that's what most of you guys put in the chat, so good job, okay? Some people forgot to do keep switch change, and I think that's what got them mixed up, right? Now, some of you are realizing, Mr. Leong, couldn't I have just done 8 in the very beginning? Yeah, let's take a look at that. Okay, so I'm going to erase all this. Right? Notice I had to do an extra step of dividing here. Let's see if we can do it without the dividing. Let's go back all the way to the beginning. And let's think about it. And let's say, you know what? I know that 8 is actually perfect. That way I don't even have to change that fraction. And I could just say, okay, well, 5 over 8 minus times 2 here, 2 over 8. So now let's do keep switch change. So 5 over 8 plus a negative 2 over 8. And that gives me 3 over 8. So notice I didn't have to do any of that simplifying, right? All I had to do was, if I already use my least common denominator, then it's already going to be simplified for the most part. Okay, sometimes you might still have to simplify, but for the most part, it'll be pretty good. Okay. Yes, you also could have just subtracted 5 minus 2. Let me show an example of when we might definitely need to use keep switch change. Let's do another one here. Okay. How about this? 1/2 minus a negative 1/5. All right. Go for it. And then put your answer in the chat. All right, make sure you do your keep switch change. Make sure you have it all there correctly. All right. Let's see. Is anyone else? Yeah, go ahead and put in the chat what you think you get for your answer there. All right, very good. Okay. So our LCD in this case, right? Most of you guys figured out it's 10, right? Not 20, not 5, not 2, it's 10. Okay. So here we go. Let's change the fractions. So I want 10 on the bottom here, so I got to multiply by 5. So that's 5 over 10 minus a negative times 2 here. 2 over 10. Okay, let's do our keep switch change. Keep. Switch. Change. Right? Negative 2 over 10 becomes positive 2 over 10. So my final answer is 7 over 10. Yeah? So again, watch out for your negatives. Watch out for your keep switch change. We know we're already, when we do the LCD, we're most likely already simplified, but double check anyway. Nothing goes in both 7 and 10, so we're good to go. So that's adding and subtracting, right? Pretty simple. We just got to find the right denominator. That's the key, finding the right denominator. So it is more difficult than what we learned before, but I think it's pretty doable. And for your homework today, you just have to do about 10 problems just like this. Now, I do want to show you one more type of problem that you'll see. I think there's an example or two on the homework. Don't write this down yet. Let me just show you an example of how this works first. Okay. Let's say you did this. It's 3 numbers in parentheses. 1 plus 2 plus 3. Right? Now you can do that in your head. And what you would do first is you would do parentheses, right? 1 plus 2 and add 3. But let me ask you this. Is this the same as 1 plus 3 plus 2? Are those the same? Yeah, right? They both get 6 at the end, right? 1 plus 2 is 3. 3 plus 3 is equal to 6. Or 1 plus 3 is 4. 4 plus 2 is still equal to 6. You get 6 no matter what. So what am I trying to tell you? Parentheses don't matter? In this case, they actually don't. When you're doing nothing but adding, the parentheses actually don't matter. You can change the order. This is what we call the commutative property. Okay? Let me write that down. You don't have to write it down. Let me just show you. Commutative property. The commutative property says that you can only add or multiply rather, in any order that you want. So let me show you an example. Okay, and again, you don't have to write any of this down. Let me just show you an example. Let's say I had a problem that looked like this. 2/5 plus, actually, sorry, let me try a different one, sorry. I'll save this one for later. Okay, so let's say I had this problem and it was negative 3/4 plus 5/9 plus 7 over 4. Now, your instinct, again, just watch this one. Your instinct might be saying, okay, I got to deal with the 4 and the 9, and I got to change these to 36th, right? Because that's the only number that 4 and 9 both go into. But I'm going to tell you this. You don't have to do that. You don't have to do common denominator. I'm going to show you a shortcut. I'm going to add these two together first, because they both have 4 as the denominator. So I'm going to rewrite it. Check it out. Negative 3/4 plus 7/4 plus 5/9. I just put it in a different order. 3/4, 7/4, 5/9. The same numbers, okay? And again, all plus signs. That's the key. All plus signs. Okay, now why did I do this? Check it out. I know that negative 3/4 and 7/4, if I add them together, I get 4 over 4, which is just 1. So I get 1 and 5/9. Notice, did I have to change any of the fractions? Did I have to change them to different denominators? No. I found a way to make things easier by the way I organized it, right? It's not cheating. It's just how things work. So let me give you guys one to do. 2/5 plus, in parentheses, 4/7 plus 3/5. I do not want you to change them to common denominator because that would take too long. Good. Some of you guys, if you see it really quick, you're like, oh, okay, I get how I can do that. Now, it might not work out pretty every time, but in this case, it makes it nice and easy. Good job. Thank you for those put in the chat. Good job. All right. Good job. Thank you. All right. So really quick, check it out. I want to add these two together first. So 2/5 plus 3/5 plus 4/7. Well, isn't 2/5 plus 3/5 5/5 or just 1? So my answer is 1 4/7. You see how easy that it could be? Right? Again, you can mix up the order. That's what the commutative property is like. Yeah. Yeah, it's a lot easier, right? Instead of changing everything to 35ths and then like simplifying after that. Now, it doesn't work so pretty every time, but this is just a shortcut if you can try to find it. Okay?